Okay, this week's topic is on indices and sets. We'll start with indices. And the index is the that bit. So first up, we'll start with the indices or index laws. And there's quite a few of these, and we're basically this week just going to be applying these, using them, and kind of looking at surds which follow similar rules, and learning how to simplify things. So I'll start up with the indices laws. If you guys can make sure you copy these down. So a to the x times a to the n, so anything to the power n times the same thing to a different power. You can add the powers together. Just common notation, we could also say a to the m times a to the n. It doesn't have to have a multiplication sign. You can just write them next to each other. Next one, a to the n divided by a to the n gives us a to the n minus n. And you could say that's also that form. So these are kind of common other forms of saying it. This is the rule. You can also get a to the m to the power n. In that case, you times them together to give you a to the mn. But again, you could also write this, because timesing is the same, 2 times 3 is the same as 3 times 2. You could also say a to the nm. Or you can say a to the n to the power n. So there's all different ways you can write these rules. Next one, a b to the n is a to the n, b to the n. And that rule still holds true if you've got a over b to the power n, a to the n over b to the n. So you need to learn these rules, and the best way to do it is to practice them as much as possible. So we're going to go through 4 quick examples now. So pause it, give those a go using these 4 rules. Okay, so first one, 5x squared to the power 3 is looking at this rule here. So everything in the bracket needs to be cubed. So 5 cubed is 125. And then x squared cubed, we're going to be looking at this rule still. So m to the power n times them together. So 2 times 3 is 6, we get x to the power 6. Next one, we're looking at dividing our powers. So first of all, 4 divided by 2 is 2. So let's sort that out straight away. And then we've got x to the 5 divided by x squared. So we're going to subtract those powers and get x to the power 3. Next one, slightly harder, because we've got 2 terms, but we're going to divide each of these terms by 2x squared. So first step, I'm going to split up this into 2 fractions. So x to the 9 over 2x squared plus x to the 5 over 2x squared. So I've kind of pulled it apart into 2 fractions with the same denominator. Now we can simplify them. So there's 1 here over 2 gives us half. X to the 9 divided by x squared is this rule. So m take n, 9 take 2 gives us 7. And next one, x to the 5 divided by that give us half. X to the power 3 using the same rule as before. Okay, last one. Again, we're going to split it up into 2 fractions. So 8x to the 12 over 2x squared minus 3x over 2x squared. And then try and simplify them. So 8 divided by 2 gives us 4. Then x to the 12 divided by x squared gives us x to the 10, using the subtraction rule there again. Here we get 3 over 2, x to the 1, take away x squared, means we're going to be left with x to the power minus 1. So mark those, look back through the video if you did get stuck on any, and try them again. Okay, so that last one, when we got a negative power, we need to know what that actually means. So that's what we're going to move on to next is negative and fractional indexes. Okay, so starting off, negative powers. Negative powers are reciprocals. And you should know the word reciprocal from when we're doing the negative reciprocal with perpendicular lines. So a reciprocal is just flipping a fraction. So if we have x to the power minus 1 like we had just now, we can say that's actually the same as 1 over x, because you can imagine x is over 1. So you could have 2 to the power minus 1, and that would be the reciprocal of 2, which is 1 over 2. You could have 3 halves to the power minus 1, which would flip the whole fraction and give you 2/3. Try a slightly harder one. You have x squared over y to the power minus 1. So if you guys want to pause and work out what you think this is going to go to. Again, you flip the whole thing, you get y over x squared. So that's negative powers. Fractional powers then. And fractional powers are roots. So for example, you could have 4 to the power half, which is going to be the square root of 4, which is obviously 2. You could have, make them a bit more difficult, you could have 16 to the power minus 3 over 2. Now there's 3 things going on here. You've got the minus, which is a reciprocal, the 3, which means cubed, and the half there, which means square root, like we saw here. The order you do those in doesn't actually matter. So if we do the minus first, because we've already discussed that, we're going to get 1 over 16, still to the power 3 over 2. So all I've done is flipped it and got rid of the minus sign. Next, I think the easiest thing to do next is to square root of 16, because it's a square number. So I know the square root of 16 is 4, the square root of the 16th is a quarter. And lastly, we need to cube a quarter. So 4 cubed is going to be 64. So 16 to the minus root of 2 gives us 1 over 64. The order doesn't matter. You could square root it first, then cube it, then flip it, whatever you like. But that's how you do that one. I need some more space. 8 to the power 2 over 3. So that's going to be the cube root of 8 squared. And the cube root of 8 is 2. And 2 squared is 4. Okay, so that's fractional powers. Always going to be some kind of root, and they often combine them with negatives and normal powers as well. Okay, there's 2 more weird bits in indices we have to talk about. So we've got 0 powers and powers of 1. So 0 powers, some of you should already know this. X to the power 0 is 1. In fact, anything to the power 0 is 1. So 2 to the power 0 is also 1. A to the power 0 is 1, etc., etc. Powers of 1, also very easy. X to the power 1 is just x. 2 to the power 1 is just 2. A to the power 1 is just A. So, to summarise everything, here's all of our index laws. So if you could write those down, make sure you memorise all of those. And now we're going to do some practice trying to use them. Okay, so we're going to go through 7 examples of varying difficulty. You're welcome to use a calculator for these if you want, because some of them are pretty hard. If you want to pause the video and try those 2, you're welcome to, or I'm about to go through them, so feel free to watch if you prefer. Okay, so the first one, simplifying this equation. We've got 2 bits to kind of simplify, top and the bottom, so we'll do the top first and worry about the bottom bit in a minute. Now, because we've got a load of stuff in brackets to a power, we need to make sure this power applies to each bit in the brackets. So first of all, 8 here, we're going to have to cube root 8 and then square it. So the cube root of 8 is 2, and then 2 squared is 4. So up here. So the cube root of 8 is 2, 2 squared is 4, which gives us that. For the other ones, we can just times the power. So 6 times 2 over 3 is going to give us x to the power 4. And y to the power 5 times 2/3 is going to give us to the power of 10 over 3. That's all divided by 4. Root x we know is x to the power of half. Okay, next step, we just need to divide these. So 4 divided by 4, they're going to cancel out. Then we've got x to the power x to the power 4 divided by x to the power half. So we're going to get x to the power 3 and a half, 4 take a half, 3.5, which is going to be as a fraction 7 over 2, and y to the power 10 over 3. Okay, the next one then. Simplifying these 2. So it might be easier if you write them out as a fraction. Five over 3 is going to stay the same, it's not going to cancel. Then we're going to have x to this power subtract this power. And you might want to use a calculator for that, ending up with 5/3 x to the power 39 over 15. Cool, right, next one's coming up. Okay, 2 more examples. These are pretty similar examples, but it's not going to be like anything you guys have really seen before. Maybe a bit in the summer work. So, in order to write this in the form 2 to the y, we need to write 16 in terms of 2. So can you think of a power of 2 that gives us 16? So 2 squared is 4, 2 cubed is 8, so 2 to the power 4 is 16. So we can write the 16 as 2 to the power 4, put it in brackets, and then put our power back into it, so 3x plus 4. Then we know from the power rule, a to the m, n is a to the m times n. We can just times these 2 together. So we get 2 to the power 4 times 3x is 12x, 4 times 4 is 16. So in other words, y equals 12x plus 16. Okay, for example 4 then, similar idea. We want to write all of this in the form 2 to the power something. So we need to start off by saying, well, how can we write 8 in terms of 2 to a power? So we said just now 2 to the power 3 is 8. So again, we can write 8 out as 2 cubed times by 2 to the m plus 2. And if I split that up, it will look a bit more like one of our index rules. 2 to the power 3 times 2 to the power n plus 2. And we know from the rule, a to the m times a to the n is a to the m plus n. So we're going to add these powers together. We get 2 to the power n plus 3 plus 2 is going to be n plus 5. Therefore, p equals n plus 5. Right, 2 more coming up. So to simplify, this is kind of similar to what we did in the examples earlier. So if you want to pause it and try these ones, pause it now and give it a go, but I'll work through them now. So we're going to split this up into two fractions. And now we're going to try and simplify each fraction. Remember, we can only split stuff up into fractions when there's one thing on the bottom. One term on the bottom, and you're allowed to pull it apart into two. So 25 over 15 is the same as 5 over 3. Taking out a factor of 5. And then x to the 1 divided by x cubed. Remember our rule. So we can do 1 take 3, which gives us x to the minus 2. Plus 30 over 15 is 2. X squared take x cubed. 2 take 3 is again going to be x to the minus 1. If we wanted, we could rewrite that as 5 over 3 x squared, and just bring it all down because of the negative power, plus 2 over x and bring that down because of the negative power. But those are equivalent answers, they're both correct. Right, next one, so quite a lot going on here as well. If first of all we worry about brackets and then bring the x in later. So we've got to cube everything inside the brackets. 3 cubed is 27. Then the x, well, we can just times those powers together and say it's x to the power minus 3/4. Now next bit, we've got two terms, x and this bit multiplied together. Which is like saying x to the 1 times 27 x to the minus 3 over 4. Which is like the rule a to the m times a to the n. This one here. So we need to add 1 and 3/4 together, leaving us with 27 x to the power 1/4. Okay, last example. Okay, if you want to pause this and try this, you can. You just need to turn each bit of this into 2 to the power something and then try and solve it. We haven't done one like this yet, but it is kind of combining everything we've done so far. So, we'll need to put each of these terms in terms of 2. So 2 to the x is fine. How can we write x in terms of 2? Or we could say 8 is 2 cubed to the power x plus 1. And we can say 16 is 2 to the power, 16 is 2 to the power 4. Okay, so we're getting somewhere. Now we need to sort out this power. So again, the index rule there is a to the m n times m. So this becomes 2 to the x times by 2 to the power 3x plus 3. So next bit, we've got two bits to combine here, which is the indices rule, a to the m times a to the n is a to the m plus n. So we're going to add these two powers together, giving us 2 to the power 3x plus x is 4x plus 3, and that's equal to 2 to the power 4. Okay, now all we need to do is find out what x is. So we can say, because these are both 2, this power has to be equal to 4. So 4x plus 3 equals 4. Take 3 from each side. So x is therefore 1/4. And we can test that by putting a quarter in here, and checking how the calculator's play is correct. Cool, alright, you should be ready now for the test on 2.1 indices, and next video we're going to be looking at sets.